For the Voice of Agriculture, I'm Bill Evans, reporting from Earthrise Farms in the Imperial Valley. Spirulina is a microscopic algae which is emerging as an important new food. It is one of nature's original life forms, which had been hidden for over 3 billion years in the microbiology of the world's lakes and ocean.
There are some 25,000 species of algae known to man at this time, but only a handful are known to be useful. And we've taken spirulina, very rich in protein, as a food for humans and pigments, and we've developed it into an industry.
I've got to admit, the very last thing in the world I would think of as being nutritious is algae.
We ordinarily don't think of that ordering algae in a restaurant. However, the fact is that some 2/3 of the world's biomass is algae, and the basis of all life in the oceans is microalgae.
What is the purpose then of the algae you produce? To refine it and to supply natural vitamins for humans, or what?
Spirulina microalgae as a whole food is incredibly rich in protein, beta-carotene, iron, and minerals. It's a very complete food, especially for, say, a vegetarian. It's very rich in protein, yet it's a plant.
Beta-carotene very effective in fighting certain forms of cancer.
Yes, the National Cancer Institute has publicized that.
When you think of carotene, beta-carotene, you think of an orange substance. When you think of algae, you think of a green or a blue substance.
Yes, our algae is a very dark blue-green. That's because maybe 20% of its weight is a very bright blue pigment, then it's loaded with chlorophyll, and these blues and greens mask the orange color.
I see.
But it's still maybe 0.5% beta-carotene, so it's really loaded with it.
In addition then to the supplemental nutritional assistance that we get from this product, is also used as a pigment, isn't it, for coloring?
That's correct. In fact, it's becoming big in Japan for providing a bright blue pigment for coloring ice creams, snow cones, chewing gum, that kind of thing.
And then a certain portion of it is used to feed fish and shrimp.
That's correct. Certain aquacultural applications require a microalgae or a very potent source of nutrition. Even if the cost is relatively high compared to normal fish feeds, it's still cost effective.
How do you go about producing the algae that you want? Because you said there are some 25,000 different kinds of algae.
That's right. Well, first of all, we have to select an appropriate type of algae to grow.
You monitor it through a lab that you maintain, right?
That's right, through microscopic methods. That's Dr. Amhabale, head of our laboratory here at Earthrise Farms. And he assures that we have the proper environmental conditions in our ponds. We add a special blend of minerals. We keep the pH just right. We control the type of predators that are present so that we get only the kind of algae, the spirulina, that we want to dominate. And our ponds are virtually 100% spirulina. That way we naturally control the weeds and the pests. We don't use any chemical herbicides or pesticides.
And when you talk about spirulina, is that the whole product or is that a derivative of the product?
That's the whole product. Like if I was to talk about Valencia oranges, instead now I'll talk about spirulina microalgae.
Okay. And once you distill that, you market it, and actually you lose nothing, not even salt in the water, because the algae uses the salt, doesn't it?
That's correct. We're very efficient, and we're proud of ourselves being good to the environment. We can come out here on the very hard land, which is almost marginal farmland.
Right.
It's very good for the type of ponds that we build. We use mineral-rich water, which is not the best for ordinary farming,
right,
but the algae thrive on it. And
the only water you lose is through evaporation.
That's correct. We only lose water through evaporation. The salts are consumed by the algae.
And the algae is removed by you and sold.
That's correct. We really, we're good for the environment.
The ponds are constantly monitored. All environmental, biological, and nutrient data is orchestrated from a lab by a skilled group of technicians. The staff is headed by world algae expert Dr. Amhabale, an Ethiopian. Earthrise is able to maintain top growth all season from May through October with precise and continuous aquatic management. Paddle wheels continually mix the ponds to assure a proper distribution of nutrients, sunlight, and live spirulina. When the ponds reach a high density, the growth rate slows and it's time to harvest. Pond water with its valuable nutrients is recycled back to the ponds. Debris and aquatic insects are removed in the first stage of processing. Stainless steel dewatering equipment separates the microfilaments of spirulina from the pond water. Concentrated spirulina is washed with fresh pond water, refiltered, and pumped back to the dryer. The drying and harvesting operations are directed from a central computer room. The spirulina paste is instantly spray dried like powdered milk inside drying towers. No additional additives or preservatives are required to stabilize this protein-rich powder. 15 minutes after harvesting begins, the spirulina has become a fine dry powder which can be stored indefinitely. The aquaculture revolution has moved out of the lab and into the Imperial Valley of Southern California. This is the first commercial process for growing spirulina in the United States. Algae is capable of transforming wastes into purified water and nutritious food for human consumption, as well as providing oxygen to support human life. For the Voice of Agriculture, I'm Bill Evans, reporting from Earthrise Farms in the Imperial Valley.